So let's play around with some of these logic gates to get a sense of what I'm talking about here. Let's first do like the NOT gate. Okay, this one's very simple. So NOT would be like this. And so now we connect it like that. Okay. And we can write this, if we wanted to make a table. Oops. So you could have the toggle. And you could have the LED here. Right? And so the relationship here is when the toggle is not pressed, so that would be a 0, the LED is on, right? And now when we were to press the toggle, the LED would be turned off, so we'd have a 1, 0. Okay? So there we go. This is our first truth table that we built. It's a truth table because it's giving a relationship between inputs on the left and outputs on the right. All right? Now, to simplify things a little bit, instead of writing down toggle and LED, we could just call this toggle, let's say, we'll use what either X. Let's see what they use in the book. Yeah, they use X, right. Right, so let's call this X and not X, which is sometimes abbreviated like that. Just put a line on top. Okay, good. So that's the truth table for the NOT gate. Let's do another one. You want to throw in there the AND gate or the OR gate, whichever one. And so now, let me bring it up on my computer. Okay, so the AND gate, you see that there are, oh, by the way, if you want to get rid of one, like say we want to get rid of this NOT gate, just drag and bring it over there to the left side. Okay, so if we look at the AND gate, there's two inputs, two yellow dots, and one output, one white dot. Okay, so that means that this is going to be a function that's mapping two variable input to a one variable output, right? So we're going to need to bring in another toggle because that's going to be another input variable. So let's bring in a second toggle. And now let's just wire it up. So there's still only one LED because there's only one output. Like this. Right, so we're actually wanting to give ourselves, we want to introduce a new variable where this will be toggle X and this will be toggle Y. Right? It's fine what you did, but that's actually not giving us the full full range of possibilities. Okay. So with two toggles now we have two input variables. We call those X and Y. Let's actually start like this. X, Y. And then what we're doing is we're building X and Y here. Okay. So we have 0, 1, sorry. So all the possibilities is they can both be off, 0, 0. We could keep the first one off and the second one on. That would be 0, 1. 1, 0, that would be the first X toggle pressed, the second one not. And then this one would be them both pressed. Okay. So what have you guys found in doing this?
Well, you can only use one toggle to turn on the LED.
So I heard two things. What's both be on? Okay. So that would correspond to this one, right? The 1, 1 when they're both on. So then we get the LED on. Right? And so in all the other cases, they're off. So we would put zeros here. Right? Good. Okay, so this is the truth table for the AND gate. And again, just like conceptually, what this is this is a function. It's mapping two variables, x and y, to one variable in output.
I have a question for you.
Yeah.
Okay, so because I was busy looking at this and not concentrating on
Uh-huh.
the actual hands.
Sure.
What were we supposed to do in order to, because I had done the numbers, just logically trying to figure it out without having the program in front of me.
Okay. Okay.
What were we supposed to be doing with, to me, it looks like a diagram, start program.
Yeah.
So what were we supposed to be doing with the program?
What we're supposed to be doing. So
Diagram.
Click the toggles and see if the LED lights up.
yeah. So you're pressing these. Yeah. Let me.
So I click the toggle.
Yeah. So right now, you see when you click it once, now it's pressed. I don't know if you can see it, make it out on the screen,
Yeah.
but it's actually gray inside.
Yeah, because I
Okay.
pressed it and nothing,
Right.
it was still, I'm
Right.
assuming off.
Right. So the way to interpret this now, this is gray inside, and that's not gray.
Right,
So this, if we call this toggle X and we call that toggle Y,
okay.
that would be like this toggle X is 1 and toggle Y is 0.
And the output is the LED.
And the output is the
And that was
LED. Yes. So that would correspond to, right now we're looking at this row right here. X is pressed, Y is not pressed, and the LED is off.
Okay.
So maybe it would help if we kind of wrote a table here. So pressed.
Now I'm gonna draw a little picture real quick.
Okay.
So
All right. I'll let.
visually know.
And if you only toggle the bottom one and not the top one, it'll also stay off, right?
Right,
Right, and that would correspond to this
It's an and.
this row here.
right.
It's gotta be the X and the Y before,
Well, both conditions, are we thinking about both conditions have to be met in order for it to come on?
that's what
Yep.
it sounds like it, yeah.
Yep.
Okay.
That's what this AND gate is doing.
Okay,
But yeah, I mean, and in fact, thank you for your question because I should have stressed this. The main idea here is that we're representing different states of our toggles using bits, zeros and ones. Okay? And different states of our LED using zeros and ones. That's the whole idea of digital information. Okay, so next question I'm going to ask you guys is let's switch the gate up. Let's build the truth table for OR.
oh, hang on.
Is there a way to get something off the screen besides, just drag it out?
You said
The only way I know is just dragging it out. I don't think there's a fast way to delete. So I would grab this AND gate, drag it over here, and it vanishes, and then replace with over to the playpen or whatever. Yeah.
picture itself,
Okay. What do we have here?
so that was a 0 at the top, 0, 0, off.
Yep.
Off, on, but that's a 1. I got a,
Is everyone agreeing?
well,
What should go here? A 1 or a 0?
One.
I got a 1.
Okay.
A 1.
Yeah.
And a 1.
Yeah. Okay. So notice this this final row here. This is where we sort of deviate from everyday parlance, right? When we say, like, do you want an apple or a banana? Right? We usually assume that you only give one answer, right? It's not like you get both of them. Whereas here you're getting a 1 when you have both as well. Right? So this would be like an apple or a banana, and you're choosing one. But here you're also turning this one on when they're both input as well. So what we're used to, I think in the English language, is something not as OR, but it's known as the exclusive OR. And I think if you scroll down and you throw this gate, this XOR in here,
And it has 2 also.
right, yep. So now let's see what this one is. I think in the book it's call it E or. Like the donkey.
I see the other one more not asking, do you want an apple or a banana,
Yeah.
but rather, do you have an apple or a banana?
Yeah, right.
The question is,
Do you have, right? So this would be a yes/no answer.
And I'm saying, I've got an apple and a banana both.
Yeah.
I say, yeah, I have an apple or a banana.
Yeah. Correct. That's a better way of putting it.
I also have an apple and a banana, but
Right.
it is, if you give me a yes or no answer,
You only
I
need
would say,
one
yes, I have an
satisfier.
apple or a banana.
Right. Or maybe something more dramatic. If you're choosing between two extremes or something. Yeah. So that's right. If you ask, do you have something is a better way.
That's a non-exclusive.
Right. Okay, so how does this one look? Right, okay. Great. Okay. So there are a few other ones there that you could play around with.
Can I ask
yeah,
you a
go ahead.
question
Yeah.
on the because I wrote a question mark
Yeah.
up here to go just a little bit into depth. Like, so here's the condition with the or and the or. And
Yeah.
the for nothing. I mean, no, on for the bottom one.
This
Yes.
one, yeah.
Both conditions in this one, and or nothing.
Right.
So, trying to understand the logic behind that one. Like, I don't know, I wrote in here, was this the difference? And
Yeah,
like, I
so-
figured like 0, 0 is 0, 1 minus.
No,
0,
no, no, no,
1,
just,
1 minus 0, 1,
um,
1 minus 1, 0.
okay.
Just
Yeah.
logically thinking.
So, I don't know if this is going to be very satisfying, but basically what you can take this as a definition.
Right,
All right? So this is defining the OR gate. This is defining the behavior.
right.
And so the OR gate has this particular behavior. This is defining another gate, which we'll call EOR or XOR. Okay? So it's just defining it differently, so it has a different set of rules. And that's really all it is.
Just the behavior.
Right, so yes, exactly. Well, these are just the rules for how it behaves. So you just take it at that.
Okay, sounds all right.
Right.